Hello, this is Geometry Topic 8-2. We're going to be talking about angles formed by secants and tangents. So just as a quick review, I have a central angle. This is x degrees, which means that this is also x degrees. A circle is 360 degrees, so since this is everything except 200, I can do 360 minus 200 and get 160 degrees. This is an inscribed angle. An inscribed angle is half of this. Well, I know that this plus this must equal 360. So 170 plus 140 is 310. 360 minus 310 is 50. That means this is 50 degrees. And this is half of that. So 50 divided by 2 is 25 degrees. Just reviewing 360 degrees in a circle, central angles, inscribed angles. This is going to talk about a new theorem. This says that if a secant and tangent intersect at the point of tangency, the measure of each angle formed is half of the intercepted arc. So even though this doesn't look like an inscribed angle, it basically is. It's the extreme of an inscribed angle where I've got a tangent combined with a secant. And this makes it 30 degrees. Well, this is half of that. So if this is 30, it means that this is 30 times 2, which is 60. Now I realize that doesn't look like just 60 degrees of the circle. That's because this doesn't look like 30 degrees of a circle. They didn't draw it accurately, and that's why it doesn't look quite accurate. But if this is 30, then the arc must be 60. Let's move on to our next example. This one looks a little bit more actual, where this is 89 degrees. We're going to want to find out what this angle is. Well, this is half of the other. So 89 is 1/2 of 11x plus 2. Well, I don't like multiplying by half, so I'm just going to go ahead and multiply by 2. 89 times 2 is 178 equals 11x plus 2. So that means 176 equals 11x. When we divide by 11, I get 16. So x equals 16. So basically, if you have an angle that's on the circle, it is half of the intersecting arc. We have a new theorem, and that is if two secants intersect on the inside of the circle, then the measure of the angle formed is half of the measure of the two arcs. So basically, these are vertical angles, so they are the same. Now, if this were the center of the circle, the arcs would be the same, but it's not the center of the circle, so the arcs are different. So what we want to do is this is 1/2 of 70 plus 30, which is half of 100. So we know that x equals 50, because half of 100 is 50. So that means that this is 50 and this is 50. Moving on to another theorem. If two secants or a secant and a tangent or two tangents intersect in the exterior of a circle, I want you to go and underline exterior of a circle, then the measure of the angle formed is half of the positive difference of the measures of the intercepted arcs. So angle on the outside equals half of the arc minus the arc. So we look at example number 6 and we go, they've only given us one arc. This arc right here is 150 degrees. But no, there are two arcs because we have another one that goes around the outside of the circle this way. So 360 minus 150 equals 210. So that means this arc is 210 degrees. So now we need 1/2 of 210 minus 150. So we need 1/2 of 60, which is 30. So this angle is 30 degrees. So, if you have an exterior angle, you know you're going to need to subtract from 360 in order to find the two arcs, because this encompasses the whole circle. So once you find that, you subtract your two arcs, divide that by 2, and you get your exterior angle. Let's move on to example number 7. I know this looks different because we have one line that touches the outside, one line that goes through the middle. It doesn't matter, it's still an exterior angle, and we're going to solve it the same way. So here we've said that 150 is all of this, and this is x degrees. Actually, no. This is 150 from here to here. Now we want to figure out what x is. So, this is one arc. This is the other arc. Okay? One arc, two arc. Well, I know that my angle equals 1/2 of arc minus arc. And I can tell by looking at it the 150 is larger. So my 40 degrees is 1/2 of 150 minus x. Well, I don't like multiplying by 1/2, so I'm just going to multiply by 2. So 80 equals 150 minus x. If I subtract 150, I get negative 70 equals negative x, which means that positive x must equal a positive 70. So x is 70 degrees. So our two arcs were split right here. We have arc x, and we have arc of 150. We subtracted those two arcs, divide them by 2, we get 40. Had I set that up as an equation, we solved the equation, we got 70. Let's go ahead and work number 8. So here, this is our divider. We have this arc, which is 4x plus 5, minus this arc, which is 50, times 1/2, equals our angle of x plus 25. Well, I don't like multiplying by a half. Well, I don't like multiplying by half, so I'm going to go ahead and multiply by 2. Those cancel, leaving me with 4x plus 5 minus 50 equals 2x plus 50. Well, 5 minus 50 is negative 45, so 4x minus 45 equals 2x plus 50. If I add 45 and subtract 2x, I get that 2x equals 95. Now I divide by 2, and I get that x equals 47.5. So again, my two arcs subtracted divided by 2 equals my exterior angle. Set it up, use algebra to solve. And in case you forget, right here we have a shortcut on what formula you need. If the arc is in the center, then the angle equals the arc. If the angle is on the circle, then it is 1/2 of the arc. If the angle is inside, it's 1/2 the sum of the arcs. If the angle is on the outside, it's 1/2 the difference of the arcs. So all the different theorems that we've talked about in 8.1 and 8.2 boil down to this. Even comes into what we talked about back in Unit 7 with central angles and their arcs. So of the whole notes, this is probably the most important piece, but you definitely want to go back and look at the algebra because that's what's going to make this assignment a little bit more difficult, is the algebra. Good luck on your assignment and have a good day.